All right, here we're going to show how to use MATLAB in a Calkit project. Now we have a fresh install of Windows 11, fresh install of MATLAB 2024B. We're not actually going to use the MATLAB application here, and I'm going to show you why. First thing we're going to do is install Chocolatey, which is a package manager for Windows, similar to Homebrew on a Mac or Yum or apt on Linux. So let's go and search for Chocolatey install. We see a command here to execute with PowerShell. Let's type PowerShell. Run as administrator. Now let's paste that command. Now we need to close and open a new PowerShell as administrator again. Next, let's install some of the Calkit dependencies. So Choco install git python vs code and UV. UV is the latest and greatest Python packaging solution out there. It's really fast. A lot of people like it. So we're going to use that, and we're going to put in -y to confirm installing all these. All right, dependencies are installed, so let's open up PowerShell as admin again, and we'll install Calkit with UV pip install system Calkit Python. Open up a new PowerShell, not as admin. Let's check the version of Calkit with Calkit -- version. All right, so we're using 0.11.3 here. Next thing we'll do is log into calkit.io, create the project, sign in with GitHub. All right, so let's create a new project, call it MATLAB test. And we'll use the example MATLAB template. Make it public. Now our machine doesn't yet have a token, so we need to set that up. Calkit config set token and paste in a token that we created up on the Calkit website. We can go to settings, tokens, create a token here, paste it in. Next step is going to be to clone this to our local machine. So let's go to GitHub, copy our HTTPS URL, make a Calkit directory. Then we're actually going to configure Git real quick, just our name and email. Now we're going to run Calkit clone with that URL. We have an error message, but it's okay because we've never run this project. Let's go in that directory, open VS Code there with code dot, trust the Calkit folder. Let's take a look at the project structure. First, we'll look at the DVC pipeline in dvc.yaml. You can see we have two stages here. They're MATLAB scripts. So we're running a MATLAB script called collect data. This is creating a Parquet file for our raw data. And we're setting the Calkit metadata in the DVC pipeline here. So we're going to note that this is a data set, and we're going to give it a title and description. Then there's a plot data script. This depends on the raw data Parquet file. It's going to produce a PNG in the figures directory, and it's going to create a Calkit figure. We're going to go ahead and install the MATLAB extension for VS Code. Let's go to the extensions, type in MATLAB, install that. Technically not necessary since we're going to be running them in batch mode, but this can be useful for interactive debugging. Let's open up a terminal and check the output of Calkit status. We can see the code's up to date, but we're missing a bunch of DVC stuff because we never run the pipeline. So let's just do that. Execute Calkit run, running the collect data stage. And now we're plotting. Let's take a look at the outputs. So we have a data.parquet file. We can see our plot in here. Now let's make sure we get this committed and backed up to the cloud. So let's run Calkit save, commit that. Go check the project homepage on calkit.io, and we can see that we have a figure up there. Next, let's modify the figure. Maybe we'll add an X label here. So we'll go into our plot data MATLAB script. We can run X label. Now we could try running this script interactively with this play button here, but I know this is going to work, so I'm just going to rerun the pipeline again. Check out our figure in plot.png, and we have an X label. Let's get that saved and backed up to the cloud. Run Calkit save again, -am, add X label. So far, we've done everything in MATLAB, but we don't have to do everything in MATLAB. Calkit's designed to support many different types of environments. So let's create a Python environment and create a figure in that. We'll do that by running Calkit new UV-venv. What this means is we're going to create a new virtual environment with UV, the Python package manager. So let's give it a name. We'll just call it Py, and then list off the packages we want to install. So we'll put in pandas, matplotlib, pyarrow to read the Parquet file, and we'll put in ipykernel so we can use Jupyter notebooks in VS Code. When we run this, we can see, if we look at git log, we had an automatic commit there for adding the UV virtual environment. And we can do git show to see what it did there. So it added this environment section to our Calkit YAML file. So we have a new environment called Py. It's referencing a path called requirements.txt. And then the content of requirements.txt is right down here. We have pandas, matplotlib, pyarrow, and ipykernel. Now I'll show an interactive workflow that I typically use, which is to use a Scratch notebook to do prototype prototyping, and then when you find something good, put it into a script and commit it to the repo. So let's make a new file. We'll just call it scratch.ipynb. ipynb stands for IPython notebook. Now I'm going to add this file to gitignore. You see I've already added scratch.m to gitignore because if there's a scratch MATLAB script, we don't want to commit this to the repo. It's just used for prototyping. But let's add scratch.ipynb there. And then let's make sure this environment exists with calkit runenv npy. And then we'll run a command in this environment. Let's just run python -- version. When we run this, Calkit's just going to make sure that the environment exists and it's up to date. Now let's open up our notebook, select a kernel. Now we'll use the .venv directory. That's the prefix of our environment, which we could see in the Calkit YAML file. Let's add a code cell, and we'll just do import pandas as pd, df equals pd.read parquet. And remember that lives in data, raw data.parquet. That'll give us our data frame, and we can do something like df.head. Take a look at the structure of the data frame. We just have this one column called voltage. Press the keyboard shortcut B to add a cell below. Now we can prototype what we want our figure to look like. So we can run df.voltage.plot. This will create a basic plot. This is going to return a set of axes. So let's set that as ax. We can do ax.set y label voltage, and ax.set x label time. Take a look at our figure again. Okay, this looks pretty good. Now that we're happy with how our figure looks, we want to turn this into a script and run it in the pipeline so we have our artifact saved. So let's create a new script in here, and we'll just call it plot data.py, and we can just cut our code out of here. Again, the notebook is throwaway, so we can just delete these cells. Don't need that head command. And then the last thing we're going to need to add here is a command to save the figure, ax.getFigure.saveFig. And we'll put this in figures plot-py.png. So we have a Python script. Now we add it to the pipeline in dvc.yaml. Let's just copy the plot data stage and modify it for our use here. We'll call the stage plot data-py. Command is going to be calkit runenv npy python scripts plot-data.py. Make sure we add that script as a dependency. It also depends on the data parquet file, and it's going to produce an output plot-py. It's going to create a calkit figure, so let's just call this the Python plot. The plot created with matplotlib. Let's take a look at Calkit status. We have a stage that's never been run here, so let's just run Calkit run. Okay, let's take a look at our figure. All right, we have a figure here. Now we got to make sure that we commit and push. However, we need to remember that we have an untracked file here, so we need to add that. We can run Calkit, add scripts, plot-data.py. That's going to add it to the Git section of our repo, not DVC. Then we can run Calkit save, add Python figure. Once everything's pushed to the cloud, we can go back to calkit.io, look at our project homepage, and we can see we have the MATLAB plot and we have the matplotlib plot. Oh, looks like we made a typo here. Let's just fix that real quick. Go to dvc.yaml, fix that, run Calkit run again, save, fix, typo. So there you have it. Here's a reproducible research project that uses MATLAB. As a bonus, it also uses Python. Everything's kept in version control. All important artifacts are created by the pipeline. Everything's backed up in the cloud. Everything's self-contained and ready to be reproduced by anyone else. I hope this was helpful. If you give it a try and run into any trouble, leave a comment below, send me a message, and I'll try to help you get it worked out.